Over the last couple of days, PartSim hasn't been very reliable. So I'm going to today to show you how to build a differential amplifier using op amps, and I'm going to use multi-sim. It's very similar. Once you can use PartSim, you can also use multi-sim. You just have to create an account, as I showed you in the other video. But anyway, here we go. I'll start with an op amp. Actually, I think I'll start with switching to full screen mode. Okay, so we're now in full screen mode. And what I'll do is I'll start with an op amp. I'll take the basic 3-terminal kind. It's grayed out. Until I click on it, it won't be completely selected. I'll click on it, and there we are. It's actually in the wrong orientation. I would like it with the inverting amplifier up. The differential amplifier is actually a combination of the inverting and non-inverting kind, but I'm going to ground the non-inverting amplifier, so I'm going to invert it. So I'll click on it, I'll get the symbols back up, I'll first do a mirror reflection, and then I'll do 2 rotations. And there we are. I have the op amp where I want it. I also want resistors. I could drag them from the side like you do in PartSim, but also something else you can do is just click on the R and a resistor will appear. So I'll click on it. It's soft. I'll click on it with the mouse, and there it is. That's R1. I'll put R2 here. Using the same process, I'll put R3 here. And I'll put R4 here. So I've got my 4 resistors. I also need a couple of voltage sources, and I'll need 3 ground connections. The circuit is linked in the information section to this video. So to get grounds, I can just type a G, so I'll do that. I'll want one here. Well, actually, let me get the voltage sources first so I know where to put them. So here's the voltage source. I select AC voltage. I'll drop it close to the first one close to R1. And then I'll go get another one. And I'll drop it close to R3. Then I'll get my ground connections. I can actually just use a G to produce those. So let's hit G, then click, and there's a ground connection. Same thing here. And the same thing at the bottom of R4. Okay, so now I'll begin wiring things up. What you do in this case is you hover near the connection point, a spool of wire will appear, and then once you have that, you can just drag it to where you want to connect. I wish I could say that was the first time this has happened to me. It's not. I'll have to hit escape. It'll go away. It also takes me out of full screen mode. I'll go back to full screen mode. And my wire is still acting up, but now I can take it to where I want it because it's at least on the screen. Okay, so I've got that wire in, and I'll drag the whole thing back into the middle. We got one connection done. I'll connect the 2 resistors together. Maybe a good idea to put them on the same line first, so we'll do that. Then we'll just wait for the spool to appear. We'll drag. We'll hit the connection. We'll click once the circle appears, click on the mouse, and we've got another connection in. The other end will go to the voltage source, so let's just do that. The voltage source is connected, and then I'll connect the ground. So that one's done. I'll connect the ground on this one. I'll connect the positive terminal to R1. I'll connect R1 to R2. And I'll connect the inverting amplifier to the junction R2 and R1. And finally, I have to connect the feedback loop, so I'll go from the resistor R2 to the output of the op amp. There we go. The other thing I have to do, got one final connection. I have to go to the non-inverting input and connect it between R3 and R4. Okay, we've now got our circuit wired up. The role of a differential amplifier is to amplify differences in voltage. So I've got V1 set to 1 volt. I'm going to go in and I'm going to make V1 be 3 volts instead. So I need to click on here. The voltage will come up. I'll just move to the voltage, click in the panel and put a 3 in place of the 1. And now I've got a 3 volt AC input. I've got this one, V2 is still 1 volt, and what I need in this case to do is, just like in the last video for PotSim, I have to show where I want the voltages measured. So I'll go grab a voltage probe, and we'll put it at the top end of the battery. So I've got one connected there. I want to the top end of the other battery. So I've got one connected there. And finally, I'm going to want the output, so I've got one connected there. You can see there are 3 different colors. These are going to be the colors of the graph lines. It works a little differently. Now that I have my probes in, it will run. I have to click on this triangle here to run the program, and it will automatically bring up the graph for me. You can see the simulation running. And I brought up the graph there. So basically, that's how it works. You can see the 1 volt, 1, and actually, but if we click over on the right-hand side, or click over here, actually maybe it's on the arrow. Yeah, if we click on the little gear wheel here, we'll see the circuit come up, and you can see that we have PR1, which is in green. It's a 3 volt input. We've got the PR2, which is in blue, which is the 1 volt input. And then in magenta, we have the output, and with the resistors we have selected at this point, all of the resistors are the same. So all that is happening is we're seeing the difference between the 2 voltages. So I'm going to go back to the schematic. And now what I'm going to do is I'm going to stop that simulation, and I'm going to change the resistors R2 and R4 so we get some amplification. So here's R2. I'll just click on this 1 ohm resistor, sorry, this 1000 ohm resistor, and change its value to 2000 ohms. I'll do the same to R4 because the changes or the resistors have to be symmetric. So we want this one to be 2000 ohms also. There it is. So we can now run this circuit. Let's stop the simulation. We'll go to Grapher. And there we have it. And you can see that in this particular case, you can still see the 1 volt and 3 volt inputs in blue and green. This time the output is amplified, and you can also see that it is beyond the scale that was set in for this particular simulation. So probably you could try smaller voltages. But anyway, that just shows you how this works. It's much like the others. You could run any of the simulations that you ran before in this one, but at this point I'll stop because you should have a good idea how to build and run circuits using multisim.